Hello guys, welcome back to part 5 of creating Procedural Dungeon Generator. In this part we're going to create the things that I have left out in the previous part. So the first thing that we're going to create will be interactable doors with its own open and closed door logic. So the next thing that we're going to create will be an elevator room, so something similar like a stairs room, but it is going to have an elevator okay, inside that room. And the next thing that we are going to create will be basically the seed system. Okay, so you will have you will be able to write your own seed, and whatever you write in the seed, you will get that specified seed. If you want a random seed, we are going to check if you have typed basically -1, and if you did, you are going basically to, every time when you spawn a new dungeon, you are going to get the random dungeon. Okay, so maybe you do not get the point what I mean, but you're going to see later. And by the way, I'm going to explain everything so you can fully understand what we are doing. So yeah, let's get started. Okay, so the first thing that we are going to do, I need to compile my code and launch my Unreal Engine. Because the first step is to actually create a class for our doors, okay, so that are going to be spawned in every entry of the new spawned room. Okay, so let me launch my Unreal Engine. Okay, and now we need to go to our C++ classes folder. So here we need to create a new class, and later we are going to create a blueprint based class from that C++ class. Okay, so let's right click and then a new C++ class. We are going to select here actor, then click on the next, and I'm going to here I'm going to name that class something like door, I don't know, something like door. Okay, so I think that's pretty right. Basic name, and it is saying that that is going to be a door. So now we need to go to our Visual Studio, and you will basically see this message right here. You just need to click on reload all. I have previously explained what is this message about, so I'm not going to talk about it again. Okay, the next thing that we are going to do, we are going to close our Unreal Engine. We need to go to our dungeon generator.header, and we are going to declare another variable. So this T subclass of a variable where we are going to declare that. Maybe here below this closing wall. Okay, so we are going to put it inside the different category. We are going to put it inside the doors. Okay, we are going to name it something like door. Okay, and we need a class a door. Okay, but before doing anything, we need to import that class. So here we need to type class and then a door above this u class, and the red line will disappear. Okay, and now we can again compile our code and launch our Unreal Engine. So there are not any errors, and here we are inside our Unreal Engine. If I click on my dungeon generator, you will see that now we have a separate category where from the drop down menu we can select the blueprint that is going to be spawned for every door. Okay, so like I said previously, we are going to create a blueprint based class from that door C++ class. Okay, we are going to store it inside pdg_files, and I'm going to name it something like bp_door. And by the way, for all of these names you can give it some other name. I'm just using these basic names, and yeah, so that's a new. And now I'll just click on create a door class. Okay, so you will see this blueprint actor door. We are just from the drop down menu, we are going to select that our BP door is going to be spawned. Now we can close our Unreal Engine, but The thing that is very important is to here click on save selected. Okay, so let's go to the dungeon generator .cpp. But before doing that, we need to actually do a thing that we can't do anything without it. So let's go to door.header, and we are going to delete these comments. So let me just delete it. I'm going to move tick below this first public, and I'm going to delete this second public. Okay, and we need basically to declare a variable, two variables that are going to be components for our door. Okay, so we are going to give it a specifier of visible anywhere, and we are going to put it inside the components category, components. Okay, and the first variable, first component, will be a static mesh component. Okay, and we are going to name it door, and the second one will actually have the same specifiers, but it is going to be a type of view box component. So this box component is actually box collision component. That collision is going to get triggered whenever we overlap with that component, and whenever we trigger that collision, we are going to trigger the logic for opening the doors. Okay, so you get the point. We need to import that uBox component class. So uBox component, and the red line will disappear. So we now need to create a default subobjects for those components. Let me just do that for the door first. We are going to do that inside our constructor. And what I did here. So let's just type door equals create default subobject u static mesh component, and here I'm going to name it just door, and now we need to do that for our box collision variable. Okay, so box collision equals create default sub object. But before doing anything, or actually let me just uBox component. So now we need basically the class of a component that we are creating. Okay, so this for this box collision we are using this uBox component class, and I'm going to name it something like I don't know, maybe box collision, a really basic name. So the next thing that we need to do, we are going to we are going to create a folder. So that folder will be a default scene root that are going to hold both of these components. Okay, and don't worry, I'm going to explain in a moment what we are doing. So we actually need another variable. I'm going to copy these specifiers. I'm going to that is going to be a class of view scene component, and I'm going to name it default scene root. Okay, and we need to that default scene root. We need to create a default subobject for that. So it is a class of view scene component, and we are just going to give it a name of default scene root, default underscore scene root. Okay, the next thing that we are going to do, we are just basically going to set this default scene root to be the root component of our blueprint. So we need to get a function that is called setup attachment, and we are going to search for root component. And the next thing that we are going to do, we are basically going to this door attached to our default scene root. Okay, so default scene root, default scene root. Okay, and we are going to do that for box collision. Okay, so now we have set up, but Okay, before doing anything we need, or before explaining anything, I need to do another step. Okay, we need to, from the components folder, to include the box component, okay, and the red line will disappear. So now we are getting suggestions for our for all of our functions from the box collision variable, and we are going to attach it to default scene root. Okay, so what we have did here, we have basically created our components inside our class. We have created one folder that is holding all of the our components, or basically our door and our box collision. So we basically can avoid a lot of behaviors that we do not want if we have one default scene root that is a main folder of all of our components. Okay, so I'm just going to say that I'm not going to confuse you furthermore. I actually suggest you to every time create one folder that will be a main folder of all of our components inside the class, and we have basically attached those components to that main folder. And you may be asking that the possible thing that we can do is attach this box collision to the door component, but that is not actually the way that we are going to do. In that way we are just going to get the behavior that we do not want. So why is that? Later we're just going to we are not going to move the whole blueprint, we're just going to move a door component. Okay, so and we are not going to move all of the other components. So we are not actually going to move this box collision along with our door. We want from our box collision to be static, to be in the place, okay, and to not be movable. I'm going to show you later what I mean by that, so don't worry, it is actually easy thing to explain and to show you, so it will get clear to you very soon. So now let's just compile our code. And after that, let's launch our Unreal Engine. So now here we are inside our Unreal Engine, and let's basically see what we have did inside our blueprint door. Okay, so let's open it. Now let's click on Open Full Blueprint Editor, and on the left side you will see that we have actually successfully created those components. So we have this folder, to say like that, that is default scene root, that is holding all of our components that we are going to use for our door. Okay, and we have this door component and this box collision component. This door component, like I said, we are going to move up and down, okay, so for opening and closing, and this box collision will be triggered whenever we want to from our doors to be opened, okay, so whenever we overlap with this box collision. Okay, and yeah, basically this is a way that we are going to do it. So the next step that we are going to do, basically we need to create our door. So here on the right side in the details panel, from the static mesh drop down menu, we need to search from SM cube. Okay, and we are going to, for example, select this SM underscore chamfer cube. Okay, we need to compile it. We are just going to do something like this. Okay, so, and later we are going to adjust the settings. Okay, so something like this. Okay, let's just increase the size of our box collision, so something like this. Let's compile it and save it. Okay, and now we have successfully created what we wanted to create. The next thing that we are going to do, basically we need to spawn spawn that blueprint on the places where they needed to be spawned, or basically in the places of every entry of the new room. Okay, so let me check out if we selected our blueprint that is going to be spawned, and yes, we actually did. So like I said, the next step is to implement the logic for spawning for spawning the doors on the every entry of a new room. Okay, so for example here, here also, here, here, and basically you get to the point. So yeah, let's do that right now. Let's close our Unreal Engine, and basically we need to go to our dungeon generator .header. Okay, so we need to basically create a new function. So we have created a function for closing unused exits. Okay, so for spawning the walls for the exits that we are not using. Okay, so we are going to do something similar like this, but we are just going to spawn the doors. Okay, so in the every entry of a new room, okay, of the latest spawned room. So I'm going to name it something like spawn doors. I think that that makes most sense. And I need to, or actually we need to create a definition for that function right here. And basically, let me see what we are going to do. I need to take a look at my other project. Okay, so the one thing that we are going to do is to copy all of these from our close unused exits function. Okay, so all of this. And now the next thing that we need to do is actually we need to create a new array. Okay, so we need to go to our dungeon generator.header file, and we are just going to create a new array that will be a type of UC component. Okay, so in this array we are just going to store the exits that we have used for spawning a latest spawned room. Okay, so I'm going to name it just door list. You can name it something other, as you can give it some other name that you want. And we need to go to our dungeon generator.cpp, and here in the spawn next room function we need to basically we need to type door list dot add, and whenever we are calling this spawn next room function, we need to add this selected exit point to that door list array. Okay, so I'm going to say it again. We are just adding all of our exit points that we have used to spawn the latest spawned room, and we are just storing them inside our door list. So and we are going to check for each element inside that door list. We are going to check for a location, and we are on that specified location for each element. We are going to spawn a door in that place. Okay, so I'm just going to reset those settings. So I'm going to basically put 0.0, 0.0, and 0.0f, and later we are just going to adjust some of the settings. And here we need to loop throughout our door list array, and here we just need to name something like latest door spawned. Okay, so and it is a class of a door. Okay, so and here we need to change to a door class, and here we need to get our door. Okay, and here we need to actually spawn that door. And let me just see something. Latest closing wall spawned. We actually need to put here latest door spawned. But before that, before doing anything or testing it out, we need to include that door. We need to include that door file. Okay, door.header. Let me just see, and I think that now we can test it out, but we actually need to do another last thing. We need to call that spawn door function. Okay, spawn doors actually, but we need to create another timer handle. Okay, so we cannot just use one timer handle for two timers. Okay. We are just going to rename this unused handle to be exits handle, and I'm just going to paste it here, and I'm going to declare another handle that is going to be doors handle. Okay, and I'm just going to put it here where we are calling our spawn doors function after 1 second. Okay, so now let's basically compile our code and let's launch our Unreal Engine in order to test it out. So here we are. Now let's just begin our simulation and let's see what we have did. Okay, so you see that we actually spawned this blueprint that we have created before. We have successfully spawned that door in each place that where they need to be spawned, or actually on the every entry of a new room. Okay, so this is a new room, and you see that we have door here, we have door here, and we have door here because this is a new room. This is a new room also, and we have a new door here. Okay, so we just need to adjust some of the settings. I'm not going to close my Unreal Engine here. I'm just going to, for the Z value of our relative offset, I'm going to set something to be like 200. Okay. You need to save it. Don't forget that you need to save it. I'm saving it by clicking Ctrl plus S, and I'm going to compile my code by clicking on this icon right here for live coding. So let me just see what we have did here. Okay, and now I think that's pretty all right. Okay, so now I need to open my BP underscore door, and we need to increase size a little bit. Okay, so let me just increase this size of our tab. Okay, I'm going to do something like this. Okay, and something like this. Okay, and you see that this is pretty alright. Okay, and now if I basically click on my box collision, we actually need to increase the size also. So let me just do something like this, and I think that's pretty alright. Okay, so also a width, and basically I'm here going to stop the simulation. I'm going to compile my code and save it, and you see that I'm using all of these options, so maybe you can copy and paste them. Okay, so you see that I'm using these scale options, and for the Z value of our location I'm using this option right here, or basically 85. Okay, so now I can close that window and again test it out, and yeah, you will see that actually we are spawning the doors inside our dungeon, and this is actually a starter room. You see that actually we are spawning something behind our starter room. Okay, so actually this starter room has spawned this room right here, that spawned this room right here, that spawned this room right here, and you see that our enter of our starter room is actually closed, but don't worry about that, we are going to fix that in some other part. Okay, and now if I basically stop the simulation and on these three dots selected viewport, you will see that actually we don't have the logic for triggering basically for closing and opening our doors. So we need to do that right now. Let's close our Unreal Engine and also this live coding. Okay, so it's closed by itself, and the next step that we are going to do is to actually go to our let me see where it is. Look, let me just close this down. Okay, we need to click on here, then source. Okay, so we need to open our PDG character dot header, and here we need to declare a new function. Okay, so we need to declare functions actually that will be for begin overlapping. Whenever we are triggering a box collision, we want to trigger the logic, some logic. Okay, so in this situation it will be a logic for opening and closing our doors. Okay, so let's do that right now. Here below protected, we need to declare a function that will be called on begin overlap. Okay, and we need to actually pass in some of the parameters. So you can find those parameters inside the Unreal Engine 5 documentation. Okay, but you can actually pause a video and just write those parameters that we need. We are not going to use all of them. We are just going to use this other actor, and this other actor is actually an actor or basically an object that we are overlapping with. Okay, so and we need another function that will be for stop, for basically on and overlap. Okay, so whenever we are not triggering the overlap or actually our doors, okay, our box collision, our door needs to go to the starter position. Okay, so we need to type void on and overlap. Okay, and we also need to pass in some of the parameters. So the same thing like here. Okay, this other actor, we're just going to use that, and that other actor is an actor that we are stopping with overlapping. Okay, they're not this boolean and this hit result parameter. We just need these, and if you want to inform about all of these parameters, you can search for official Unreal Engine 5 documentation. The next thing that we are going to do, we need to create a definition for that functions. Okay, and we just need to move that function down there. Okay, and we need to do that also for our on and overlap function. So okay, so that's actually a good place for our function. The next thing that we are going to do, we actually need to let me just see, we need to bind our on begin overlap and our on end overlap function with our character. Okay, so we are going to do that in the begin play. So we need to get capsule component. Okay, so from this class. And we need to search for on component begin overlap, and we just need to search for add dynamic. And don't worry if that add dynamic is not suggested to you, it is still going to work. Just type add dynamic. So we need to basically pass in this class right here, and the function that is going to be called will be our on begin. On begin overlap. Okay, and we need to do that for our on component and overlap. Okay, so we are just going to copy this, and here instead of begin I'm going to pass in end. So on component and overlap. And the function that is going to be triggered will be on and overlap. Okay, so I think that is the name of our function, and that is actually okay. So now the one thing that we want to check if we are successfully triggering the box collision of our doors. Okay, so the one thing that we are going to do, we need to basically check if our other actor has a tag. And you may be asking what we are doing here. and I'm going to explain in a moment what we are doing here. I'm just going to check for interactable dungeon doors. Okay, so we are going to use this tag to add the tag to every door inside our dungeon that is spawned, and basically we are checking if the actor that we are overlapping with has this interactable dungeon doors tag, because later we are going to have several actors, and those actors are going to have a separate or basically different tags. Okay, so now we are just going to print a simple string. So gengine add on-screen debug message -1. It is going to be shown for 5 seconds. The color will be, let's say, emerald, and the text that is going to be shown is like something like start overlap. Okay, overlap, and we are just going to do that for our basically on end overlap. So here I'm just going to pass in the end overlap string. Now let's compile our code, and let's basically launch our Unreal Engine after that. And here we are inside our Unreal Engine. Now the next thing that we need to do is to go to our bp_door. We need to open full blueprint editor, and in the details panel we need to search for tags. Okay, so we need this advanced, or actually from the actor we need this advanced and then these tags. We are going to, oh, actually not that, but let me just go to my Visual Studio and copy this tag right here. So we need to add that tag. Okay, so let's compile and save. And now if we begin my simulation, something is not right. Okay, so let me just see. Okay, so now if I basically trigger, or basically if I overlap with my box collision of my doors, actually nothing is going to happen, and I think that I know the reason for that. So we need to go to our pdg character.header, and here we need to type u function. Okay, and for this on and overlap function too. Okay, so we are not going to write anything inside that u function. Okay, so let's basically compile our code, and after that let's launch our Unreal Engine. Now if I basically begin the simulation, you will see that our doors are spawned, and if I basically overlap with my doors, you will see that we are actually in the top left corner we are printing a string. Okay, so for start overlap and for end overlap. I don't know the reason why we needed to here type a u function, actually, to be honest, but yeah, every time when you're declaring these two functions, you need to basically type here u function above them. And later I'm actually going to do some researches about this, but for now that's not important. Okay, and as you saw, we are triggering the logic, and we are printing the string, and we can finally create a logic for opening and closing our doors that are spawned in the dungeon. So the next thing that we need to do, we need to go to our door.header, and here we need to basically declare some things. We need to declare a few variables. Okay, so let's do that right now. The first variable will be a type of an f vector. That will be basically a start location of our door. Okay, so of our door that we want to open and close. So we are just going to store here the start location. Okay, so the f vector is storing basically the x, y, and the z value of that of something, of location of some object, okay, and in this situation that will be a start location of our door that we want to open and close, okay. The next variable that we need to declare will be also the f vector, and that will be actually an end location. So what I mean by end location, the end location is a location where our door is going to move whenever we want to move, to open actually our door, okay. So whenever I want to open my door, our door is going to move down, okay, and we are just going to be able to go through that door, okay. So we are just going to be able to go into next room, okay. So you get the point. The next variable that we need to declare will be also the f vector, and that will be a current location. I don't need to explain for this. Current location is a current location of our door, and you will see that we are actually going to store the current location in the event tick. So in the every second we are going to store the current location of our door, okay. The next thing that we need to declare will be a boolean, and that will be basically should move, okay. So b should move. That boolean we are going to basically check if we are moving our door. So what I mean by moving, I mean if we are closing it and if we are opening, okay. So at the moment if we are closing and if we are opening, our should move will be true, okay. The next thing that we need to declare will be actually I don't know if we actually need to, but yeah, we are going to do that in that way. We are just going to declare a move speed, okay, and for now it will be a 10.0 f, okay. So move speed will be basically a movement speed of our door that is going to move whenever we want to open or close our doors, okay. So you get the point. And the next thing that we need to declare will be a function, actually two functions. So the first one will be for opening the door, and the second one will be for closing our door, okay. So now the next thing that we need to do, we actually need to basically create a definition for that two functions. So let me just do something like this, and we need to do that for our closed door function. Okay, so the next thing that we need to do, we are going to actually initialize our start location variable, okay. So we are going to do that here inside our gameplay, okay. So we need to type start location, okay. So we need to get this variable right here. Start location, that is basically a start location of our door that we want to open and close, okay. And we need to give it, or actually we need to get a door, and we need to get a relative location from that door component, and by this we are getting the start location of our doors. And I don't know if you remember, but I said previously that we are just going to move this door component, okay, and we are not going to move the whole blueprint actor, okay. So the next thing that we need to do, we need to actually initialize our current location variable, okay. So we need to get this current location, and like I said, we are just going to do that inside the tick. So basically the same thing, we're just going to get the relative location from our door component. And the one thing that we are going to do is basically we are going to check if our should move boolean is true or false, okay. So we are checking if our platform should move or not, okay. And now we are going to declare a new variable, so that will be basically new location, okay. So from the fmat we need to get a function that is called vinterp2, okay. So basically if I hover on it, you will see that we are interpolating vector from current to target, and basically scaled by distance to target, so it has a strong start speed and ease out. Basically we're just going to move our doors more smoothly. Okay, so first we need to pass in the current location, and we need to pass in the end location. And you may be asking why we are basically initializing this start location. You will see in a moment, so don't worry about that. We need to pass in a delta time. Okay, so and the last thing that we need to pass in will be our move speed variable. Okay, so that is this variable right here that we have declared previously. Basically we are just going to get our door component, and we're just going to set a relative location. Okay, and we are going to pass in a new location. So what we are going to do next, we just need to get this b should move, and we need to set it to be true inside our open door and close door function. Okay, so it doesn't matter if we are opening or closing our doors. Our door needs to basically move. Okay, so it should move. And now we need to pass in the end location, or actually we need to calculate the end location when we want to open our door. Okay, so we need to get the current location, and we are going to subtract that by f vector. So we need to type 0.0f, 0.0f, and something like maybe 300 minus 300. Okay, so we basically want to subtract the z value of our current location, and that will be a calculation for our end location. Okay, and what we need to do, or what we want to do whenever we want to close our door, we're just going to initialize this end location to be basically our start location. Okay, and I think now that we can test it out, but actually we need to go to our let me just see, to character class. Okay, so pdg character.cpp, and whenever we are overlapping with, we are just going to do one thing. We need to cast to our door class. Okay, so we are just going to do that in this way. Okay, but before that we need to include our door file. Okay, so door.header, and the red line will disappear. And what we are going to use for our reference, we're just going to use the other actor, or basically the actor that we are casting, that we are actually overlapping with. Okay, here we are just going to call open door function, but we're not getting the suggestions for that function, so I think that we just need to move those declaration of our functions below the public, and now we are going to be able to call that open door function, and yeah, we are actually able to do that. And here we're just going to call close door. Okay, and now I think that finally we can test it out. So let's basically compile our code, and let's launch our Unreal Engine after that. Okay, so here we are inside our Unreal Engine. If I basically begin my simulation, wait for my doors to be spawned, and now the next thing we need to do is basically to test it out. So if I trigger my box collision, nothing, or actually what we are doing here, we are actually moving, I'm actually moving my door to up. Okay, so let me just see what I have did. We need to go to our door.cpp, and yeah, I see actually here we need to delete this minus, and actually I'm going to increase it to be, for example, 500. Basically we don't need two minuses, because two minuses are giving us a plus. Okay, so don't forget to save it by clicking Ctrl plus S. Now I'm going to compile my code by clicking on this icon right here for live coding. Okay, so there are not any errors. If I basically now begin the simulation and test it out, you will see that actually we are opening and closing our doors. So yeah, that's actually a great thing that we have did. Maybe we can decrease our value of our z value to be, for example, 400. So let's save it. Let's compile our code again. Okay, so there are not any errors. Let's see what we have did, and yeah, basically that's a little bit better. So now the next thing that we are going to do, basically we need to create a seed system for our procedural dungeon. So yeah, let's do that right now. I'm going to close my Unreal Engine. So basically the first step that we need to do is to go to our dungeon generator header. Let me just find it where it is. Okay, so go to your dungeon generator header, and we need to declare a new variable. Okay, so we are going to do that below the protected, and I'm going to do that below this declaration of array of this door list. We need to type f random stream, and we are going to name it just random stream. Don't worry, I'm going to explain what is this random stream. Basically, this random stream is some kind of a generator of a bunch of random numbers. It can help us about seeds, and you will see in which way that can help us. Okay, so the next thing that we need to do, we actually need to declare another variable. And we need to give it a specifiers of visible, or actually edit anywhere, because we need to be able to set the seed that we want. Okay, edit anywhere, and we are going to set it inside the seed category, or actually I'm going to set it to be inside dungeon info category. Okay. It will be an integer 32, and I'm just going to name it seed. You can name it something that you want. You can give it some other name actually. Okay. And now the next thing that we need to do, we need to go to dungeon generator .cpp, and actually we need to declare another thing. We need to declare a new function. So I'm going to name it something like set seed. Okay, you can again you can give it some other name. That's a new. So let's create a definition for that function. Okay, so now the next thing that we need to do. I said previously that if here in the seed, if we type -1, that we are going to basically get the random seed, and if we basically set some specified seed, okay, we will get that exact seed and that exact dungeon each time when we begin simulation. So yeah, again, if when we are in our Unreal Engine, and in the details panel for this seed, if we type -1, we are going each time to get a random seed. Okay, so we are actually going to check. We are actually going to check if that seed is -1, and we are going to declare another variable where we are going to store the results. Okay, so if our seed is -1, the results will be some random numbers that will represent the random dungeon. Okay, random seed, and if it's not, it is just going to be this seed that we have typed in the engine. Okay, so we need to get these results. and we need to type equals fmat, and from the fmat library we need to get a rand function. So basically, let me just hover on it. Okay, so that rand function is returns a random integer between 0 and this. Okay, so and this rand underscore max. Okay, so don't worry about that. We are just going to each time get a random number. And if our seed is not -1, or actually if we do not want the random seed each time in the random dungeon, we just want to initialize these results to be anything that we have typed in that seed. Okay, and the last thing that we need to do, we just need to type random stream. Okay, and we need to initialize that random stream. So we are just going to pass in these results and like you see, initialize the random stream with the specified seed value. Okay, so okay, I'm going to explain again. If our seed is -1, we are just going to get a random number each time, and our results will actually initialize. Our random stream is going to be initialized with a random number, and if it's not, if our seed is something specified, we are just going to get that exact seed that we have typed, and we are just going to pass in that information into our results, and we are going to initialize our random stream with that results. Okay, so I hope you get the point. And another thing we can do, we can actually print, or actually do we need to do that? But yeah, why not? We actually can print a simple string, so we can basically print these results that we are getting. Okay, so some kind of something like debugging to see if we are getting the right results. Okay, it will be shown for 5 seconds. The color will be, let's say, red. Now we need to type f string, and from the f string we need the printf function. Inside that we need to type text, and then we need to basically type this string %d. Okay, and comma, we are just going to print results. Okay, because results is integer, and here we need %d. Okay, and let me just okay, so now we are just going to basically call that setSeed function. Okay, so we are going to do that above this function right here, this spawn starter room function calling. Okay, and we just need the semicolon at the end. Don't forget that, otherwise you can get an error, and you're not going to see for a whole hour. Okay, and it will just take your time. Okay, now the next thing, we are actually I'm actually going to compile my code, and I'm just going to launch my Unreal Engine because I want to show you what we have did for now. Okay, so let's launch our Unreal Engine. Okay, so our Unreal Engine is launched now. If I click on my dungeon generator, you will see on the right side below this dungeon info category that we have this seed right here. Okay, so we can just specify as exact seed. Okay, so something like 2, 3, 4, and 5. Okay, and we are just going to get basically the dungeon with that exact seed and that exact dungeon. We still need to do another thing before making it work, but don't worry. We just want to see if our if this seed right here is getting shown on the top, in the top left corner as a print string. Okay, so let's see, and yeah, it is actually. And basically, if I here type -1, we're just going every time to get a random seed. So let's test it out. Okay, so you'll see that we are getting this seed right here. Let's again begin the simulation. Okay, we are getting the different seed. Okay, and again, and again, and again. Okay, so we actually have succeeded with that. Now we need to do another last thing. So here I'm just going to close my Unreal Engine, and here I'm just going to click on Save Selected, and we need to do another last thing in order to making it work. Okay, so the thing that we need to do is not a big deal. So basically here we just need to declare a new variable that will be basically an integer 32, and I'm going to name it a room index. We need to type equals and then random stream, okay, random stream dot rand range, okay, what I did, rand range, and basically here we need to type 0. And it will go from a range from 0 to a max range that will be this rooms to be spawned dot num. So basically a length of our rooms to be spawned -1. Okay, so that will be a maximum value. Okay. And here we just need, instead of this, we need to pass in this room index, and this is a way that we are using random stream. So we need to do the same work for this line of code right here. Okay, so we need to declare a new variable, and I'm just going to name it exit index equals. We are just going to copy and paste it, and I just instead of this rooms to be spawned.num, we need just a length of this exits array, okay, -1, and that will be basically our exit index. So basically from this random stream we are getting actually a number in the range from 0 to this number right here, okay, whatever this is, and basically here we're just going to pass in here exit index, okay, and basically now finally I think that we can test it out to see if we have successfully created or implemented our seed system into our procedural dungeon generator. So let's wait a little bit. Okay, now if I click on my dungeon generator, you will see that we are actually I have actually set my seed to -1, and if I click on these 3 dots and click on simulate, let's see if every time we are getting a random seed. Okay, so okay, we are actually getting a random seed. That's actually a cool thing. Okay, and also our doors and the closing walls are getting spawned. And now if we basically stop the simulation, and here on the right side type something like 2, 4, 5, 6, 6, okay, so that will be our seed. If I now begin my simulation, we will get this dungeon right here. If I stop my simulation and run it again, you will see that actually we are going to get the same dungeon that we have basically got previously. So yeah, actually that means that we have successfully implemented the seed system, and if you take a look, we are still getting the same dungeon. We have successfully implemented the seed system inside our procedural dungeon generator, and the very last thing that we need to implement for this system, and I think that that's not important, but yeah, I actually decided to make that to actually show you how to do that. That will be basically an elevator room, so something similar like this stairs room. It is actually not a stairs, but imagine that that is. So it will have an elevator inside that, and it is also going to be a room that is connecting the first with the second floor. Okay, basically we need now to create a new class for our elevator room. So we need to go to our C++ class folder, and then to this folder right here. From the room base, we need to create a C++ child class that we are just going to name RB underscore elevator dungeon elevator room, actually RB underscore dungeon elevator room. Okay, and now we need to click on create class, and now we need to basically I'm actually going to close my Unreal Engine, and you will see this message right here. Like every time, we need to click on reload all. So the one thing that we are going to do, we are actually going to copy all of this that we have declared inside our dungeon stairs room 1. We are going to copy that and paste that inside our RB underscore dungeon elevator room. Okay, so something like this. We just need to change this constructor. So ARB underscore dungeon elevator room. Okay, so now the red line will disappear. Let's create a definition for that constructor. Okay, and basically, let me see if we need to add something, and I think that we actually we are going actually to rename these stairs to be a platform. So that will be or actually let's name it elevator. So that will be elevator that that will move us to the top, to the second floor. Okay, that will transport us. Okay. And we actually need to declare. So actually there are few things that we need to declare too. Let me just take a look at my second project. Okay, so we need to declare a variable that will be basically box collision component. So u box component. Okay. And we need to also declare, let me just see. Okay, so I have floor 2. Why I have floor 2? I don't know actually, but never mind. The one thing that we need to do, we just need to copy and paste that 3 more times. And don't worry, you will see why we need to copy and paste that 3 times. Actually we need 4 actually floors, so floor components. Don't worry about that. And I think that now let me just change this elevator to something like box collision. Okay, that makes sense. And I'm just going to open my dungeon stairs room 1.cpp, and I'm going to copy all of this because I don't want to do all of this again. I'm just going to paste it here. I'm just going to rename this to platform, and I'm just going to change the name to platform. Okay, elevator, not a platform. Okay, so elevator. And now we need to include the arrow component. So from the components folder, we need to include arrow component, and the red line will disappear. So for the stairs, we are just going to do that for the elevator. And we need to create a default sub-object for our floor components. So I'm just going to copy and paste it 3 more times actually. So this is 2, this is 1, this is 3, and this is 4. Floor underscore 1, floor underscore 2, 3, and 4. Okay, and we actually need to create a default sub-object for our box collision component. I'm just going to do that here. So box collision equals create a default sub-object u box component. Okay, and I'm going to name it something like I don't know, maybe, okay, just box underscore collision. I'm trying to be creative about names, but I don't know. I hope you get the point, and if you don't, please reach to us throughout our Discord server, or basically you can contact us throughout the comments, and our team is going to help you. Okay, and now we are just going to attach that box collision to be a child class of our elevator component. So setup attachment, but before that we need to include from the components folder, we need to include the box component, okay. And now we need to search for a function that is called setup attachment, and we need to attach it as a child component to our elevator. And now we have did many things in a short period of time, but don't worry, you will see why we have declared all of these components, why we have declared this elevator, why we have declared this box collision, and don't worry about that. Oh, actually, I think that I have left out one thing, so we need to attach those floor components. Okay, so something like this. Okay, floor 2, floor 3, and floor 4. And finally, I think that we can now compile our code and launch our Unreal Engine after that. Let's see if there's any errors. Okay, so something is not right. One failed. Let me just see. Actually, if you take a look, let me just go to our room-based.header. You will see that we have actually declared a component that is called box collision. Okay, so I totally forgot about that. And I'm just going to name it something like elevator collision. And also we need to basically get this elevator collision, and we need to instead of this box collision, we need to pass in this elevator collision. Here I'm just going to rename it to be elevator underscore collision, and also we need to change this box collision to elevator collision. And I think now that we are not going to get any errors, so let's compile our code and let's launch our Unreal Engine after that. And so now we can basically open our content drawer, and from the RB underscore elevator room, I can't find it where it is. Okay, so RB underscore dungeon elevator room, we are going to create a blueprint child class, and we are going to store that inside our pdg underscore files. I'm going to call it something like bp underscore dungeon elevator room 1. Okay, so create, click on create, don't forget it. And now go to your pdg underscore files folder, then open your dungeon elevator room 1. So let me just, you need to click on open full blueprint editor, and actually, okay, so actually, sorry about that, but we are going to delete that blueprint class that we have created, and we are just going to basically duplicate this dungeon stairs room 1. Okay, so we just need to rename it to dungeon elevator room 1. Okay, and we need to open it, and we need just to reparent it in order to get the components that we are going to use in order to create our elevator dungeon room. Okay, so just click on class settings, and then here in the parent class from the drop down menu we need to search for RB dungeon elevator, okay, elevator room, and just click on reparent. So you will see that we actually we've got some additional components. So those are like let me just find them. Okay, so that is this like this, for example, elevator, and then elevator collision. That is a child class of that elevator component, and also these floor components. So don't worry about that. Don't worry about that. We are going to adjust some of the settings. So the first thing that we are going to do, I'm going to show you why we have created 4 of those floor components. So we will basically need a small hole in the center of the room for our elevator. So what we are going to do, we are just going to scale this floor to be something like this. Okay, we are just going to copy scale values, and for the floor 1, on the right side for the static mesh, we need to search for SM cube. We need to compile it in order to get this drop-down menu for our material, and I think that material that we have used is basic asset 02. And I'm just going to paste this scale value. Let me just see. Okay, so for the z value of our location, we need to pass in the 1700. Okay, and I'm going to move it to the right. Okay, so something like this. And you see, when we do for this and for this side, you will see that we will have a small hole for our elevator in the center of our room. Okay, so let's just here we need to search for SM cube. I'm just going to search for material that is called basic asset 02, paste the scale values, and for the location, for the z value of our location, we need 1700. Actually, we need also to rotate this, and we actually need to adjust the location. So what is this? Okay, so something like this, and we need to do that for the other side too. The last one is floor 4 component. Okay, so let's search for SM cube. For the material, we need to search for basic asset 02. We need to paste the scale values, and for the value of our location, we need 1700. We are just going to rotate it for the 90 degrees. Okay, so we just need to adjust that location. Okay, something like this, and you will see that actually we are getting this small hole in the center of the second floor, and that is the reason why we have declared those 4 floor components. Okay, the next thing that we need to do, we just need to basically for this elevator on the right side, we need to search for SM cube, and this will be basically that platform that will transport us from the first to the second floor. Okay, so we are going to compile it. We are going to search for basic assets 02 material. Okay, so we need to increase the size of it a little bit, and I'm just going to move it up, and you see that actually our box elevator collision component is actually following our elevator component, because that is a child component of our elevator component. Okay, so let me just move it something like this, because I want to center it. Okay, so I'm just going to increase the size and do something like this. Okay, I think that this is pretty alright. So now I'm just going to move it down there, because if we want to go up, our character needs to step up on it. I'm actually going to do something like this. Okay, and we need to adjust the size of our elevator collision component. So first we are going to move it something like this. We need to increase the size. Okay, so this is pretty alright. I'm just going to move it something like this. Okay, let me just check it, and we are just going to increase a size, so something like this, and I think that actually, okay, something like this, and this will be perfect. Now we have created a look for our room, and finally we can implement a logic for our elevator, and we can add it to our list, in which we will choose what rooms will be spawned. Okay, so let's now close this blueprint. Let's click on Dungeon Generator, and let's here for the rooms to be spawned, let's add another element. We need to search for BP Dungeon Elevator Room 1. Okay, so there it is. Now let's save it. Let's close our Unreal Engine, and finally we can implement a logic for our elevator that will transport us to the second floor. So we are going just to do something similar, or actually most of the process that we are going to do will be same like we did for our let me just see, for our door. Okay, so we are just going to use this logic right here. We are going to use this interp2 function that will move our platform, or actually elevator component, smoothly. Okay, we are going to initialize to get our start location. We are going to in each second get the current location, and we will basically do, like I said, most of these things the same. So let's go to our dungeon elevator room .header, or actually go to your dungeon elevator room .cpp. And if you take a closer look, you will see that actually we don't have event tick, or actually event begin play, and we also need two functions. So one that will transport us up, and the one that will where our elevator will go back to the start position. Okay, so the first thing that we are going to do, we are actually going to declare begin play and event tick. So we need to type virtual void begin play. Okay, so that is actually an override function. So don't forget that we need this override, and also we need to type to declare our tick function, or actually in the blueprints this tick function is called event tick. We need to pass in the parameter that will be a type of float, and that will be just delta time, and that is also override function. So let's create a definition for them. Okay. And for the begin play, we need to type super, and from the super class we need to get to begin play in order to get the usual behavior of the event of begin play function. Okay, so for tick we need to type super. Okay, not like that, but like this. Super, and then from the super we need a tick, and we are just going to pass in a delta time. And one thing that we need to do, we just need to go to our constructor, and we need to basically enable our tick, or basically we need to do something, and after that we are just going to do to make our tick work. Okay, so here in the constructor we need to type primary actor tick, and from the primary actor tick we need to get b can ever tick, and we need to initialize it to be true, to set it to be true, and now our tick is going to work. So the next thing that we need to do, we actually need to declare a few variables, and I'm just going to copy them from the door .header. So those are like start location, end location, current location, b should move boolean, and move speed. Okay, so I'm just going to copy and paste them inside our dungeon elevator room .header. And now below the public we need to declare two functions. So one will be basically a void function. That function is not going to return anything, it is just going to do some work for us, and one will be go up, and one will be go down. So go up will transport us to the second floor, and the go down will basically, whenever we stop triggering the elevator collision component, basically our elevator is our platform is going to go to the start position. Okay, so let's just create a definition for them. And one thing, or actually we are going to do that later, never mind. Now we are going to do the same process like we did in the door.cpp. We are going to copy this. In the begin play, we are going to get the start location by getting this wait, let me just see. From this elevator we need a relative location, and that will be our start location. The next thing that we need to do, we actually need the current location in the each second. So okay, this is a little bit boring. So current location, and now we are getting the current location from our elevator by getting the relative location of that elevator. And now we need to check if our boolean b should move is true, and if it's true, we need to declare a new variable vector new location. Basically, that new variable is going to be a type of f vector, or basically a type of variable that has three values, x, y, and z. I'm going to name it new location, and from the fmet library we need to get a function that is called vinterp2. Okay, and now we need to get the current location. The second thing we need, so if you take a closer look, we need the current location, we need a target location, we need the delta time, and a speed of our moving speed of our elevator. Okay, so and location. The next thing is delta time, and the last thing is move speed. Okay, so and the next thing we are just going to basically get our elevator component, and we are going to set relative location to be actually this new location. And like I said, we are using this vinterp2 function to move our elevator smoothly. Okay, so more smoothly. What now? What we need to do? We actually need to calculate the end location. So whenever we want to go up, we are just going to calculate the end location to be current location plus, or actually minus. No, not minus. We want to go up. Okay, so that will be plus. So 0.0f, 0.0f, and we just need to go up. So we are going to set something like 1500. Okay. And b should move needs to be true, so needs to be true. We are just going to copy and paste that, and whenever our elevator needs to go down, we just need to our end location needs to be our start location, because our elevator needs to go to the start location. Okay. And actually, I think that we have did all the work inside our dungeon elevator room class. The next thing that we need to do, we need to go to our character class, okay? And we actually need to do another check here. So we need to do another check here that will be for our elevator. Okay, so we are just going to search for interactable elevator. Okay, so that will be our tag, and we actually need to do that for on end overlap. So let's get to that interactable and interactable elevator tag. So later we are going just for our blueprint, we are going to edit that tag. Okay, so now we need to cast to our RB underscore dungeon elevator room. But before that, we need to actually include it. So like we did for our door. So let's search for RB underscore dungeon elevator room, and now we can use that class. So a RB underscore dungeon elevator room, there it is. And for the cast, we are going to use the other actor. And now we need to call a function that is called go up, and whenever we end with overlap, whenever we are stopping with triggering the elevator collision component, we want to go down, or actually back our elevator component to the start position. So basically, like we did for our doors, we are doing a similar process for our elevator. Okay, so I'm just going to copy this interactable elevator. I'm going to compile my code and launch my Unreal Engine after that. Okay, and now I just need to open my BP_dungeon elevator room 1, and I'm just going on the right side in the details panel. I'm going to search for tags. Okay, for tag, and here below the actor, and then advanced, and then tags, we need to edit a tag that will be interactable elevator. We just need to compile it and save it. Okay, and now let's first see if our elevator room is getting spawned or not, and it is actually getting spawned. Now we just need to play with our character, and okay, so now we need to find an enter for that room. I don't know where it is, so okay, so we have found it, and let's test it out. If okay, so what's this? Okay, so weird behavior of our elevator. I think that the problem is that we need to actually increase. We need to decrease it a little bit. So indicate we need to do something like this. And actually, I'm going to turn this off, and I'm going to do something like this. And now let's test it out. And now, if I test it out, you will see that actually we are getting the same dungeon. Okay, because the seed is same. Let me just see. Okay, now if I basically step up on it, it will go up, and if I stop triggering the elevator collision component, it will go down to the start position, and if I again step up on it, we will go up, and actually, yeah, we have succeeded with making an elevator for ourselves. Okay, so we can basically just decrease a little bit z value. Okay, so the value of our let's just see where it is. Okay, so the value of our end location, basically of our calculation. So something like 1450. Okay, so now let's go to our Unreal Engine. Let's compile our code throughout live coding, and let's test it out now. Okay, so let me just see. We are again getting the same dungeon, by the way. Okay, so now, and yeah, that's pretty alright. Now you see that it is better than it was previously. You can basically test. You can basically play with the options, and you can just find a best option for you. So yeah, basically we have finally created our elevator room, and we have finished. We have did all the work that we had for this part. And this part is already long enough, so I think that we are already about an hour and a half in, so enough for this part. Thanks for watching. Please guys, if anything is unclear, feel free to reach to us now throughout our Discord server, and you can actually write a comment down below this video. So thank you for watching. Don't forget to subscribe, don't forget to leave a like, and like I said, the most important thing, if anything isn't clear, don't forget to reach to us, and our team is going to help you. So see you in the next part.